Building Science 101 is sponsored by Anderson Windows and Doors, Builder's First Source, Huber Engineered Woods, Polyguard, Sashco, and ViewRail.
All right, my friends, Building Science 101, water management. This is literally the most important episode on the series. Where do we start on this, Steve?
So my personal mentor, Joe Stiebrick, one of the greatest qualities I think Joe has, I think it's his number one quality, is the ability to simplify a concept.
Mm-hmm,
right?
For sure.
He's a very smart guy, but when you talk to him, he talks to you like you're a kindergartner learning about water management.
Which is what we're doing today.
Which is what we're doing today. Not that you're kindergartners, but you get the point.
Right.
So I have been thinking long and hard about the 4 control layers, and I broke each one of them down to 3 basic concepts.
Okay.
So we have water management. I have a really simple building section here, but you can see there's 3 different arrows. Those 3 different sets of arrows are for 3 different words. Protection. And you're going to love the word protection because that goes back to your umbrella analogy.
I love that.
Right?
Yeah.
I mean, when you think about it, our roof is nothing but an umbrella to the house.
That's right. We want that water that comes from the sky to be shed off and not even touch our building.
We want it to go away, right? The easiest way to prevent a leak, don't let it see water.
That's right.
Right? So if I can keep my walls dry, then I'll never have a leak at a window if it never sees water.
That's right.
The second word here is mitigation. So mitigation's a little different than protection. When we talk about water, remember we talked about water management. So management suggests that we give water a path to go. We need to mitigate it, right? Yep. So we need to find a path for water to go. When it hits our building, we can't let it go into our building.
Mm-hmm.
We can't let that happen.
Yep.
We need to give it away someplace to go. We need to get rid of it. 2 of Joe's favorite words, if I had $1 for every time I heard him say down and out, I could have retired already.
That's right. Down and out.
Right? Get rid of it.
That water that comes from the sky, if it doesn't get protected from the umbrella, then we need to mitigate that water.
Yes. We need to get rid of it. It's such an easy concept, but yet it's the number one, and I'm going to say this very slowly, killer of buildings.
Yeah, for sure. And we mentioned earlier, it's 80% of construction defect litigation is water related.
Right.
So this is really the most important control layer.
Yeah. So think about it for a second. If you're a builder who builds buildings, if you're an architect that designs buildings, and if you're a client that purchases buildings,
mm-hmm.
What would be your number one concern? The number one thing that kills your buildings. I know this is pretty fundamental, but you know what? There are hundreds of building scientists and people of the like that are making millions of dollars, lawyers making bajillions of dollars in lawsuits due to water.
That's right.
That simple water drop.
That's right.
So, continuing down, 3rd word, prevention.
Define that for us, Steve. What do you mean by prevention?
Prevention means we need, like this, an Alamo. Now, when I last presented, I talked about, hey, every building needs an Alamo. And then someone raised their hand and said, but Steve, we lost.
Everybody got killed from the Alamo.
But I'm using the concept of the Alamo. We need a last stand.
Yeah, a place that nothing gets beyond here. This is the place that nothing gets beyond.
Right. We need something that says, hey, water, you're not getting by me. I am the final barrier.
That's right.
Now, our goal in mitigation is that we put as little water as possible against that last stand.
All right, we don't want to challenge it more than necessary, right? And depending on the style of architecture, that can be more challenging. If we've got parapet walls and no overhangs, those walls may see almost as much water as our roof, whereas if we have a building like this diagram you're showing that has a 2-foot overhang and some gutters, we're only maybe going to get water on that wall when we've got a little bit of wind or heavier rain with some bigger rain droplets.
Yep. So We could dive into these a little deeper. When we talk about protection and we talk about an umbrella, one of the things that I like to talk about is this aspect ratio. And the aspect ratio is what is the X distance of my overhang versus the Y distance of my first leakage point. Basically the head of the window.
Right, which is usually your first leakage point.
Which is the first leakage point. And honestly, years ago, I did probably a 6-month study with another fellow building scientist where we traveled around the country and we were working with all the large flashing tape companies. We were installing windows at different places. We were testing them. We would isolate windows, put them under negative pressure, try and suck water through. But the reality is most of the windows leaked at the head of the window. Now, the water might have appeared at the sill because that's where it accumulates.
That's where it came in.
But where it comes in was up at the top and the head of
I've seen that a lot as well.
Unprotected. So that aspect ratio, in my buildings, if I want it to be a very favored condition, I want it to be 2 to 1. So 2 foot overhang, about the top of the window, about a foot below it.
Got it.
And that 2 to 1 really gives me really good protection.
Which also means that if you've got a 2-story house, this is maybe a 1-story that you're showing on this diagram, but if it's a 2-story house and that overhang's way up there, maybe 20 feet in the air, those first floor windows are pretty exposed.
They're very vulnerable. And that is, in the production builder's world, like those sliders on the first floor and a 2-story wall are killer.
They are really prone towards leakage.
Yeah,
that's right.
Exactly. So 2 to 1, 1 to 1 is okay. When I start getting less than 1, I need to really start thinking about the flashing details on the window. I need to start thinking about who's doing the flashing details on the window.
Yeah.
Right. As an architect, that I have some builders that I work with all the time. There's some builders that, okay, if that was 6 inches to a foot, I'd be like, yeah, this builder, he can handle it.
Yep.
But I have some builders I'd be like, hell no, we need 3 to 1 with this guy.
Right.
Or gal.
Yeah.
Right. And so, my dream in protection is to find the right client. I want to do a house that basically has a minimum of about 4 or 5 foot overhangs and then never flash the window, just install it and tape it off. Because our risk is totally tied to these 3 words.
Yeah, it's funny that you mentioned that. We haven't said that word risk yet, but that's really what we're managing here, is we're managing that risk. If that water gets past the Alamo, in these modern buildings, remember this isn't the house that's in the Prairie example, the church that has the kiln inside that has plenty of airflow and no insulation. Modern buildings, when that water gets in, it doesn't take much to overwhelm the system. And remember, if it can't dry, it's gonna die, my friend David Nicastro says. So if that water is getting in at the head of windows every time it rains, there's not gonna be a good ability for that to dry. Now, on a one-time event, you have a storm that happens once every 10 years and you have some crazy wind and some water gets in, you're probably not gonna have a long-term issue. But if every time it rains, or every other time it rains with a little wind, that water gets in a modern building, there's no good mechanism for drying. We don't have that hairdryer effect on our walls. So that means that step 2, that mitigation that Steve's talking about here, is vital. And in the 201 series, we'll get into more of the specific methods. This is meant to be a 101. We'll talk more about rain screens and air gaps and products and how we assemble those things. But in this 101 series, we want you to understand that water needs a last stand. We need that control layer, that water management layer that we've really spent the time and effort and detailed correctly. And I've heard you before, Steve, say that when you're interviewing builders, when you're talking to a potential builder as a client, I don't want to steal your thunder. Will you take the quote?
It's really interesting because if a client is sitting across the table from a builder or an architect, the client's number one concern usually is aesthetics. Like, are you a good enough builder to make my house look pretty, right? Are you a good enough architect to make my house look pretty? But here's the deal. If the prettiness fell short by 10%, you're not going to be pissed off,
right?
Because you're not going to build it until it's pretty with the architect. And, some of the details, the builder might not have as much experience as another builder, and might not perform, but you're not going to be totally aggravated.
Yeah.
If you walk into your house and the hardwood floor by your sliding glass door is buckling for about the first 4 feet, in the first 6 months, you're going to be one very pissed off client.
That's right. That's right.
But as much as I would love to say, hey, it is the builders and it is the architect's fault, which eventually it falls on them, as the client, you have to sit across the table and ask the question of, hey, Mr. Builder, Mr. or Mrs. Architect, what's your water management strategy?
That's right.
How are you going to ensure that I'm getting the best product I should be getting and the one that I'm paying for?
Yeah, that's right. And to piggyback on that, Steve, I think one thing that we need to think about in this 101 series is the more challenging and the more risky the architecture is, especially when it comes to this water management, the harder it's going to be for us as builders to build that house to 100%. Here's an example. I live in Austin, Texas. I would consider this kind of a medium climate when it comes to rain. We get about 35 inches of rain annually. We're not Arizona desert that gets under 20 inches. We're not the Pacific Northwest that gets 40 plus and gets it all winter long, but we get 30 some inches. Now, if you build a building in Austin, Texas that has no overhangs, that has roofs with parapet walls and valleys and hips and all kinds of intersecting walls with roofs, that's a challenging building. That's a building that has very little forgiveness built into the architecture. And so I need, as a builder, to make sure I get every detail absolutely perfect. On the other hand, if I build what Steve's showing here is a diagram of kind of a standard looking house with some overhangs, maybe even a one-story house, a ventilated attic, that's a less challenging building, frankly. That's a building that has some forgiveness built into the architecture, built into the design of the building. And so as we think about this Building 101 series here, Building Science 101, I need you to think about the challenging nature of both your climate, where you're building, and the style of architecture. And if we could take a second to rewind time, if we think about the buildings that were built 100 years ago across America, there was iconic styles for buildings in those areas. We think of Adobe style houses maybe in the Southwest. We think of the New England colonial style house, maybe where you grew up, Steve. Those houses were designed and built in an age where we didn't have insulation. We didn't have a whole lot of concerns about future energy and energy codes. And we also didn't have all the chemistry and the products and the desire for some very specific control, like we mentioned earlier. So as a result, the houses in that area kind of were built and designed in a style that worked with the climate. And if we look at wherever you are watching this, if you look at the older houses, the houses that were built 50, 75, 100 years ago, I suspect that there's a style that was a smart style that worked in your climate zone. If we forward that to today, we see in all kinds of climates, all kinds of different styles. But I'm not necessarily harping on modern architecture or no overhangs, but as we think about this water management strategy, it's really, really important for us to remember that water is the #1 killer, that most of the defects from construction are somehow water related, and that's where the lawsuits come from. And if we go back to that building science definition that I said very early in the series, building science is the collection of scientific knowledge and experience that focuses on the analysis and control of the physical phenomena affecting buildings and architecture, really the same thing. And the practical purpose of building science is to provide predictive capability to optimize the building performance of new and existing homes. We like optimized performance, but it's also, and this is the one that really resonates for me as a builder and why I care so much about building science, understanding or preventing building failures in guiding the design of new techniques and technologies. I've had lots of building failures over the years. I've experienced lots of them. If you know my story and my history, in the early 2000s, the mold crisis hit America, and on the nightly news, NBC News, Tom Brokaw was talking about the mold crisis. Insurance companies were paying huge mold settlement claims with homeowners and builders. And as a young builder in my early 30s, I experienced that pain of homeowners that felt like their leaky building was going to kill their children because of mold issues. And I had been building for several years and kind of doing what I always did and felt like, oh my gosh, the world is coming to an end. What's going on? That's when I started digging into building science, learning from a bunch of different mentors and trying to figure out what is it about building today that's different from 20, 30, 50 years ago, and why are we having these problems? So this building science definition, understanding or preventing building failures, ultimately is a water issue. And as I said earlier, we're going to get into the very specific details of how to do that on our 201 series that we'll be filming hopefully in the not too distant future. But we wanted to present the case and talk about the general strategies.
Yeah, I mean, these are the things that you need to be talking to with your builder. And, you bring up a good point, adobe structures in the Southwest, colonials in New England. The two words that kind of sort that out for me are climate tuned.
Climate tune, that's a
You
good
don't
word.
see an adobe house that has a parapet wall in New England,
Yes,
right? You don't. And you very rarely see a colonial with overhangs and stuff in downtown Phoenix,
that's right.
right? So the builders in those areas understood where they were building.
Yep.
And then they built appropriately to that risk.
Yeah.
Right. So, you mentioned about the mold crisis. The worst case example that I know of when I was at Building Science Corporation, there was a house in the Northwest that was so badly mold infested. The homeowners turned it over to the fire department and used it as a practice house and burnt it down because it was that far beyond repair.
Holy cow. It goes right back to that. If it can't dry, it's gonna die.
It's going to die. And this one died a very quick death.
Yeah, that's for sure.
But all right, moving on. Mitigation, right? So when you think about mitigation, we put sidings on our houses, or let's even make it more collective and say exterior finish, because it could be stucco, it could be something else, brick, masonry. So it's not necessarily siding, but every house has an exterior finish. That exterior finish's purpose is first, to look and feel good. Like I want my house to look pretty. But the main purpose of that exterior finish is to get rid of as much water as we possibly can.
Yeah, and secondarily to keep UV rays off of whatever's behind it.
Vulnerable materials.
Yeah.
Exactly. So Joe had a really good term for that. He called it the sacrificial layer. Right? You put it out there, the sun beats on it, the rain beats on it, the water freezes on it in Minnesota. That outer exterior finish layer is getting tortured.
Yeah.
Basically. But we're concerned about what makes it behind that layer.
The Alamo.
Like the Alamo. Now, a lot of you are going to say, well, nothing's getting back there, Steve. We seal it up really good. I mean, Jimmy the builder, he went through 3 cases of sealant on my house. Here's what I know about building science, and this is 30 years. It's only a sample of one. The minute you break out a caulking gun, a roll of tape, or some type of adhesive closure membrane, the very first question you should be asking, what am I sealing in, not out?
Oh, that's great.
Right. It's real easy to believe, okay, well, I'm going to keep water out. Well, yeah, of course. That's why you're caulking that joint. What if water gets behind that?
Oh, I got a great quote for that. Can I use it? David Nicastro, it's not about keeping water out, it's about letting water out. So to your point, if you had a water issue and your solution is a caulk gun, something happened wrong in that project.
And 10 years of building science, I can honestly say we never investigated a building because the sealant worked.
It's a great point.
Right? Nobody ever calls because, hey, the wall's staying dry, the sealant worked. Guess what they call about?
Yeah.
Hey, the builder went through 3 cases of sealant, but our wall's still rotting out behind the siding.
Everything we put on the outside of our houses, to your point, Steve, siding, stucco, masonry, brick, rock, whatever it is, that's the layer that's draining that water and is kind of the first line of defense to shed that water. It's also keeping everything behind that from getting UV rays on it, because just about everything we use in our houses is UV sensitive. But that Alamo, to your point, Steve, is back behind that. That's your house wrap, that's your zip system sheathing, that's whatever you're using on top of your wood structure. If you think about our buildings in North America, they're generally wood structured buildings with some type of control layers. And we're talking about specifically the water management layer today And then on top of that is a cladding. That cladding is going to let some amount of water through it. And in our 201 series, we're going to get into rain screens and air gaps, ways to mitigate water and to provide a drainage path and a way for that water to get out. But in this 101 series, you need to know that that Alamo layer, that last line of defense, that's the line of defense that's got to be waterproof and needs to shed the water and drain the water. Remember, it's always down and out. That's why we're using flashings, head flashings on our windows. That's why we're putting sill pans underneath our windows. So if our windows leak, they've got something that's waterproof to leak onto, and then they can drain down and out.
Yeah, and you bring up a good point. Having that either building paper or whatever the case is, two terms come to mind, right? Behind our exterior finish here, we need what's called the drainage plane, right? So what is the drainage plane? The drainage plane, if we believe in management and we believe in mitigation, we need a path to go and we need to provide it. So the drainage plane is that stopping point, but not only do we want to stop water, but we want to give it someplace to go.
That's right.
That down and out, right? That's where that comes
from. It's about letting water out.
Right. And that also that drainage plane, it's very commonly referred to as the WRB.
That's right.
Or weather resistive barrier.
There you go.
Right. So that is our last stand, weather resistive, like it's stopping everything at that point. And it's the first time in this whole series where we've used the word barrier.
That's
right. So the difference between management and barrier is a stopping point.
Yep, that's the Alamo.
That's the Alamo. That's where it all ends, right there. So we're either successful or, like the Alamo, maybe not so successful. But our hope and strive for is to be successful at that layer.
While you're thinking about that word barrier method, why don't you, let's talk about window installs, because I know you've got some good knowledge for us on ways to install windows, including that method.
So mitigation, we've shown it here as a very wide spectrum concept. But all three of these words also relate to every component that we put inside the building. So the minute I cut a hole in here and insert a window in there, then that hole now, or that window, is taking on the life of the WRB because the WRB doesn't exist there anymore.
Yep.
So now my water has to do things like, or the window has to do things like, it has to protect itself from water.
Yep.
Right. And most of the time, the good window companies are taking care of that. Like, they're not selling you a leaky window, right? They're providing you that protection. But all of the good window manufacturers also have mitigative solutions to their windows,
right,
their components. If water gets in, they have weep holes so the water gets out.
That's right.
So they understand that the window, while we think of it as a barrier, it really isn't. It's a water-managed assembly of components that deal with it. And of course, prevention in the window, again, we don't want water sitting on our windowsill, so the window is preventing that. But that's true of every component.
Yeah, for sure. And then I'm going to steal your thunder a little bit, but there's really two ways to install a window. There's the barrier method, and most American windows are flanged windows that has both a flange to structurally install the window, and that's a flashing point that we'll use to kind of stop the windows or stop the water from getting past the window. And the barrier method basically means that when we install that window, we're flashing all the way around it, typically with some type of tape or sealant. And that is an approved method through AMA, the American Architectural Manufacturers Association. But in our experience, that is not the best method to install a window. We don't like that method because that method assumes that that window will never leak for the life of the window. And there are some manufacturers that are better than others, but we want to assume that windows might leak someday no matter the manufacturer. And so we actually would prefer, instead of the barrier method, to do
a water-managed system.
Yep.
And a water-managed install, where we give water a path to go. We assume water is going to get into that rough opening.
That's
The
right.
question is like David and Castro said, how do we let it out?
Yeah. So as a result, you'll see us when we do our videos talking about all the different systems, no matter what it is. Every system of WRB has some type of sill pan that you can integrate with that. Often it's from the same manufacturer. Maybe that could even be like an older house is a metal sill pan, or some of the houses I do will create a metal sill pan, but a way that if water were to get past that window and leak into that rough opening, gravity is going to bring it down to the sill. So we want that sill to be waterproof. And we also like that sill to have some slope to it, so that if water does hit it, it's going to be sloped towards the outside rather than running to the inside. The other thing we're going to do is when we install our windows, instead of doing a barrier at the flange on the window on the outside, we're typically going to do just the two sides and the head, and then we're going to leave the bottom with some method to weep water out if some small amount of water got into that window. Now remember, windows are going to vary on their potential for leak. And we talked about earlier, first floor windows on a 2-story house have more potential for leakage. Windows that have a giant overhang, a giant golf umbrella, less potential for leakage. And it's really going to depend on the type of window and the amount of exposure that window has. But what we like to do when we're building is just assume every window has some amount of exposure. No matter the manufacturer, no matter the type of architecture, we'd prefer to go to that best practice, avoiding that barrier method and go into that water management method.
You know, the point about orientation, 2-story wall or this, there's this thing out there called a windrose. Now, I have a really good example. I've been trying to find more of them. They are just, they're eluding me on the internet.
I don't know what this is.
So a rain or wind and rain rose is basically, if you look at a compass, right? And we have north, south, east, and west. What they are it's a plotted graph of the direction and how much rain that an orientation gets. So for New England, I want to say it looks something like this, right? Where most of our wind and rain comes out of the northeast. The southwest exposure really doesn't get that much rain. So you're a little in New England, right? But that's going to change depending on where you are.
This is so for me down here in Texas. I actually typically think of most of the storms and wind coming out of more of the south and west in Texas. And the other thing too to remember is exposure, right? If you're building a house on a hill, if you're building a coastal house, they're going to have a lot higher amount of exposure than maybe a house in the plains.
Well, we did that house that you toured, the one on the coast.
Mm-hmm.
And I remember telling you, I said, you know, as an architect, one of the coolest things was getting a commission to build an 8,000 square foot house on the coast. Guess what one of the scariest things in architecture is? Getting a commission to design and build an 8,000 square foot house on the coast.
Yeah.
Because exposure and understanding, just like we wouldn't build the same house in Arizona that we would build in Boston, we wouldn't build the same house in the town that I live in the suburbs of Boston versus, say, one on the coast in Gloucester.
Yeah, that's right.
That is just going to get hammered and pounded with wind and rain.
Yeah.
It's got a totally different dynamic. And, you know, the other thing that I joke about, but it's true because it's one of those jokes that you can laugh because it is so true. You think about the homeowners that are building a house on the coast, right? If they have money to purchase that land and buy that house, they probably have a little bit of money left over to hire a lawyer should they get in trouble.
That's for darn sure.
Right? So not only does the risk go up,
Yep.
but they're not the little people that say, hey, I know you tried your hardest. If you could just come and fix this window. That's not how those conversations go
No.
on a $10 million house on the coast.
No, that's right.
So if you're building them, you really got to step up your game and pay attention to that risk, because that risk isn't a permanent graph. It's different for everybody. It's different everywhere you are in the country, and it's different in every microclimate. In every 50 or 60 miles, there's probably different positions where that risk changes.
Yeah, and we'll get into this into the 2-on-1 series, but just as a general overview, if you think about the window that you're going to buy off the shelf at the home center, you know, a vinyl window that's, in the $150, $250 range, compare that to some other windows that cost 4 or 5 or 10 times more expensive, you just naturally assume you get what you pay for. And that is true to a large extent. And in 201, we're going to get into something that we don't have time for today, which is design pressures. And how is that window that's more expensive going to have a better water management system? So we need to think about those components that go into our system and the level of exposure. You know, a one-story house built in the plains, standard house wrap, kind of standard off-the-shelf materials, probably going to work fine as long as that house has overhangs. Two-story house, no overhangs, modern architecture, we got to spend a lot more money both on the WRB system, the drainage plane system that we're going to spend. We also have to spend more money on the window and door package, and we've got to make sure that all those flashings, all those details were done with the best labor and knowledgeable labor to understand how to install those correctly, because the smallest amount of error in those buildings will cause a problem.
Yeah. So continuing on with the mitigation issue, right? We talk about the Alamo and we talk about that sacrificial layer. Matt has mentioned a number of times about a rain screen system. What it basically is the suspension of our exterior finish in front of the drainage plane, so there's a space that runs down in between.
That's right.
Why is that so important? I'm going to give you a little story, little primer on that, something to think about. If I built a wall with a window and I sprayed water on it, that wall is going to get significantly challenged. The window is going to get significantly challenged. If I build a secondary wall and I put it 4 inches in front of that and I spray it, that inside wall is going to see 1/100th of the water that it saw when it was fully exposed. So that rain screen system is that suggestion. Put something in front, that sacrificial layer, it takes the beating, it sheds most of the water. What little water does get in then just simply falls to gravity inside that space.
Yeah, that's right, for sure. And our grandparents knew that because they built a lot of buildings with brick. And brick naturally has that air gap behind it. The mason's finger width is about 1 inch. And so as they laid that brick, there was about 1 inch gap behind the brick and before the face of the structure. Oftentimes there was no WRB behind those buildings, and it was just brick, but that air gap gave a lot of forgiveness. It meant that we managed that water in a very early attempt to make a water management system.
And you'd like to believe that everybody's a professional and understands how to do their job. And I would love to believe that. But I have knowledge of a building. It was a brick veneer. The brick was mortared solid to the WRB. There was a building paper over plywood. The brick was mortared solid in. But this is the kicker. When the homeowner called a friend of mine to come and look at the project, the homeowner also gave him a small tidbit of information. We just redid the mason, right? Because the original build had brick fully mortared to the WRB. The mason came and blamed it on the WRB was failing.
Oh my God.
So they stripped the whole house of masonry,
Did it again.
put up the WRB, and then mortared the brick solid.
No. Terrible.
And I'm sure he was a great guy, a nice guy, thinking that he knew everything. But as the client, you might want to ask a few of these questions. I mean, on the other side of the spectrum, most of my clients come to me because of the building science. Hey, I want to build a house that lasts forever. I want to be able to give it to my kids.
Yeah.
This and that. Well, with that comes all of these buildings. Steve, last night on the internet, I read this. So can we use this material, or why would we not use this? So like half of my association with them is discussions in building science, because they really want to get in tune with it. But if you're the kind of client that says, hey, Jimmy the builder, just go build it, I trust you, you still should ask a few general questions of, hey, how are we going to mitigate water in our wall system? What kind of windows are you using? Do they have a weep hole system? Are you using caulk on my siding? If you are, right? Does that water behind it have a way to be let out?
Let's try a pathway out.
So, well, we still have the third word.
Oh my gosh, we didn't get into
Prevention. I mean, we did kind of touch on it.
We did touch on it a little.
Right, because it's the down and out, get rid of it, all of that, having sloping ground, having rain gutters on your house,
Yep.
and getting rid of it, right? That's another level of mitigation or prevention, that whatever I take off of my protection, it goes into a rain gutter, and then that goes out to a system and gets away from the house. But groundwater, that's one of those things where you have to worry about it in both directions.
Mm-hmm.
Because in some cases, you're simply talking about groundwater coming in here. Now, we talked about climate tuned. I know of building investigations in Las Vegas where it was a water management investigation.
Mm.
It was due to the sprinkler.
In the desert.
So it was manufactured rain, but nonetheless, it was a water management problem. Water is the number one killer, not rain, water.
That's a great point.
So
Really good point.
you have to worry about the water coming down, but you also need to worry about hydrostatic pressure of water coming up.
Yeah, building up against that foundation, and that pressure, that hydrostatic pressure, could turn your basement into a submarine.
Yeah, definitely. And the whole idea of prevention down here, basically what we're trying to do is prevent water from going into our basement and having it flood.
Mm-hmm.
It's actually, the basement is probably one of the hardest to detail, because there's a lot of money can be spent on prevention down there, but if it's a relatively low risk, then you might not have to spend all of that
Mm-hmm.
money in that budget. So the game in the basement is really, really one of what is my risk, or what is the potential for it to get wet. I did a couple houses on the Vineyard. I use that as an example because there's probably about 20 feet of sand.
Martha's Vineyard.
Martha's Vineyard, yeah. And you can literally get a 5-gallon bucket of water, pour it, and it disappears right in front of your eyes. Like, it doesn't puddle, it doesn't leave a darker ring. It's gone.
Wow.
So it is, when you say free draining, it's probably one of the best examples.
That's the opposite of where I am in Texas, with all the clay and rock
With
around.
all of the clay and the rock. So if you're a homeowner and you go out there digging your foundation and you see the side of the excavation seeping water in a puddle, forming down at the bottom of that hole, your first question to your builder should be, and your architect should be like, I see water coming out there. I'm concerned about that. Do we have a prevention process so that water doesn't end up in my basement?
That's a great point.
Right.
Will you on your diagram show us a few of those general water management details below grade?
Yeah. So one of the things that I would typically put, I always call out, and only because there's so many systems, I call out for a waterproofing, and it's usually somewhere in the 60 mil range. And the waterproofing, now, when you put a waterproofing on there, that keeps the water out, but you have to maintain the integrity of the waterproofing. And what I mean by that is, it goes on nice and neat, but guess what happens right after it gets done? Some guy jumps in his excavator, he grabs that pile of dirt and rocks, and he swings it over and just dumps it freely. And so you get those rocks bashing at it.
Yep.
So I always call for a 60 mil waterproofing, and the waterproofing doesn't stop necessarily at the bottom. You want to take it over the footing because there's a cold joint down here.
Yeah, that's right.
And you don't, and I have seen projects where water has come in through there.
For the cold joint.
Now, a lot of people will put a capillary break on top of that. There's some stuff that you can trowel on. There's membrane type systems that you can put on there. I think there's a manufacturer that makes a caulking there that they can put in there. And on a project recent project of ours, there's a company that makes this little bentonite clay like cube, and you can put it right down in there, and just like you said, that clay expands. Well, the minute that gets wet, it expands and basically seals up that joint.
Kind of a cork in the wine bottle kind of feeling there.
Exactly. So the 60 mil, but what you want to do here is you want to put some type of protection board or drainage measure.
Yeah, I was going to say, I'd add the word drainage on there too, a drainage and protection board. So that when you do backfill, you know, of course, we're going to have, you notice on his diagram, he's got crushed rock down there at the footing drain, and there's usually a filter fabric over top of that crushed rock. So water that gets down there is going to have a hollow tube that's connected to a low point, a sump pit, and the sump pit has a sump pump in there, which actually pumps that water out, assuming that it's not a place to daylight it to go below with gravity feeding to go out. But that drain board or protection board, whatever you want to call it, makes sure that the waterproofing isn't challenged because of what Steve mentioned earlier, backfill issues, or even really heavy rains that allow that water to kind of rise up. It gives an air gap in front of that waterproofing and in front of that concrete foundation. So any water that's flowing towards the foundation is going to hit that air gap and go all the way down to that footing drain where it can be pumped out.
Yeah. Or drain the daylight. In some cases that have it. But you made a good point. You know, the stone underneath here, that's basically battling capillary rise.
Yeah, that's great. We should definitely talk about that for a second.
And capillary rise is nothing more than a material's ability to move water, you know, vertically by virtue of the material that is there, right? So obviously stone really can't move water, but if that was dirt right up to the underside of the slab, that water could migrate all the way up. And concrete is a sponge.
Yeah, that's
right. So that water wouldn't stop there. That water would continue to rise up through there.
Yeah, we didn't necessarily mention that, but that's a great point to say that, you know, remember that both concrete, brick, rock, masonry exteriors, those are not waterproof materials. Those will wick water just like a 2x4 will wick water. And so when our brick veneers get wet, when our concrete foundations get wet, they can soak up a lot of water. And that capillary break that Steve mentioned, we're going to use that between our basement slab and the crushed rock that's below there to make sure that we don't have any wicking. We're also going to use a capillary break where our concrete meets our wood framing for the house. We call that a sill sealer, and its main intention is to stop any capillary action, any water that's wicking from that concrete to actually touching our framing above there.
Yeah. And, you know, you bring up a good point about the brick and stone and that. But the thing about brick, stone, all of that, guess how they're attached? They have mortar joints.
Mm-hmm.
That mortar joint has a very high level of risk. We actually did a test. We were doing a building investigation, and we turned on the spray rack and went inside to see how long. It was something like less than 90 seconds. We had water coming through the backside of that mortar joint.
Holy cow.
Like it was just sucking up the water and
I've seen that there.
through.
Yep.
So
it's in effect a big sponge on the outside of that.
Yeah. So don't think, hey, I put up brick because I can't punch through it. Doesn't mean Mother Nature can't get through it with some water.
That's a great point.
Right. Mother Nature always wins.
Yeah.
She always wins. Eventually, if we build a building, it might last 50 years, it might last 100 years, it might last 300 years, but it will never last forever.
That's right.
Mother Nature will overcome.
That's right.
And win. But, you know, the takeaways today, Matt, I think if
protection number one.
Protection number one.
Don't let it see water.
Don't let it see water. If it does, mitigate it.
Provide a pathway for that water.
Provide a path. And number three, prevention.
Stop it at the drainage plane.
Stop it at the drainage plane and give it a pipe. Get it the hell away from your house. Make the water somebody else's problem.
We're going to have a 201 series eventually. I'm sure I'm probably teasing this too early, but we wanted to give you the big concepts today. We didn't want to get into product or specific applications. There's so much to say on that. But this is a really important module for you, whether you're a seasoned builder like Steve and I, or whether you're a young builder or a soon-to-be builder. You need to understand this water management layer, this water control layer on our buildings. If you haven't watched the other part of the series prior to this, this is good elemental foundational knowledge. So I'd recommend if you started here on this series, back up, watch the other episodes, because you need that knowledge to kind of build to where we're getting today. And with that being said, stay tuned. Our next control layer we're going to hit next is the air barrier layer on the house. Very, very important to control air as well. This episode of Build Science 101 brought to you by our friends at Huber Engineered Woods. This is the maker of Advantech subfloor and the zip system sheathing that you see so much on our houses under construction. These guys are a long-time supporter and friend of the Build Show. Steve, how long have you been using their products?
I've been using Zip Wall ever since it came out, actually. I remember the first time it came out, I was introduced to it. Questioning how good this system could be because it was new integrated weather resistive barrier, right? Trying to get rid of house wrap. And I was doing my first passive house at the time.
Wow.
So we built a full scale mock-up of Zip and we zipped over all of the openings except the one we did the blower door, 0.32.
Holy cow. You're like, oh, we're on to something here.
We're on to something here. The system works. The system works.
My intro to Huber Engineered Woods was Advantech. You know, I built my very first custom home in Austin, Texas, 2005, and it rained during construction. And all my plywood seams, even though I had 1.125" plywood, the heavy, good stuff, expensive stuff, all my seams buckled on me. You know, it was my first house I built as a custom builder, and I didn't factor in that extra, I forget what it was, like $800,000 to come in and sand all the seams on a 4,000 square foot house before the hardwoods got put down. It was a big deal. I mean, it busted a budget for me big time. So I said, all right, there's gotta be a better product. I did some research. I came across 1.125" Advantech. They also make it in 3/4, of course. And you know what, once I used it, that house got rained on. I had no sanding, no buckling, no change. I was sold. I've used it ever since.
We actually did a slabless basement system where we did 2 layers of Advantech. The house got flooded, 6 inches of standing water. We pumped the water out, dried the Advantech. It was like brand new.
Holy cow, that's an amazing product. Now here's my intro to the zip system sheathing. You know, when it first came out, 15 plus years ago or so now, I was a bit of a detractor. I thought, you know, how could we be dependent on tape for a system? But you know what? I saw what they were doing at the J.J. Pickle Research Center with the University of Texas Construction Durability Lab. It's like a mile from my office here. And I saw samples of all the different house wrap products on these racks facing the Texas sun, weathering for years at a time. And when I first saw that, it had been out for a couple of years in the sun, and I couldn't believe the damage that all the other systems had, whereas the Zip system looked almost brand new.
Yeah, I have 2 pieces when we did that house. We taped them together, they put them on my wood pile. They've been frozen, rained on, snowed on, sun beating down on them. We're going into our 14th year. The tape is like brand new.
Holy cow. Great company, great products, and lastly, I want to mention great tech service. If you need any help from these guys, they've got an amazing team that can help you with your technical questions. You can learn more about these guys at huberwood.com, or of course, the Gram's a great place too. They have a great social feed at Huberwood. Steve, good job, man. This is a great episode. Thanks for hanging in. It's a little bit longer than the others, but remember, this was the #1 killer of our building, so we need to spend a little extra time. With that being said, we'll see you next time on The Build Show.